Okay, so we have to do even a seventh recording for for this particular test. I think this is the last one. We need to call it G, if according to the way I've been doing things at least. Math 108, Spring 21, Exam 2 Review, and it is it is G. Okay, so we've got three more problems, which would be 18. To start off with, there's some reward program for buying some product, and they're willing to do 0.25 cents, which is not much, a quarter of a cent, for each code scanned. Each code scanned, and I guess it goes to somebody's account or something, whatever, and it goes to a reward program. Goes to a reward program. Okay, some sort of promotion or whatever it is. Now, furthermore, there's a code. We just said the word code, right, for each code. So here's how the code works. Let me give it its own separate line. The code has got one digit, right, number, one digit, and then followed by, then, I'm putting this word in then to be clear, then there's four letters. That's what the code has. One digit, four letters. Now, D and E, for whatever some reason, D and E are not used. They're out of the running. And and besides that, that's as far as the letters are concerned. And as far as the number is concerned, 0, 5, and 8, you know, you've seen my ampersand before, are also not used. Okay, so what does this come out to be? Now, if Alex decides to be generous, they'll be very nice. They'll explain that, you know what it comes out to be, that you only have 24 letters that you can use because two are out, D and E. 24 letters you can use. If they don't, you'll have to figure that out yourself, that there's 26 letters and minus two letters that are off limits, so it's 24. And also, and then what else can you use? You can use only 7 digits because 0, 5, and 8, 3 out of the 10 are gone. So you only have digits. So if they're very generous, they'll tell that to you. If not, you'll have to figure it out yourself. So in seven, this is what's fair game. These are the fair game stuff. One more piece of information. Repetition is allowed. So if you choose an A for the first letter, you can choose an A for the second. Repetition is perfectly allowed. Is allowed. Okay, that's a very important piece of information. It makes a big difference. All right, here comes the question. There's all the information. Here comes the question. How many codes are possible? Are possible. Okay, now let me move up the paper so you can see what we see better, I believe. Okay, slow, stop. I want you to see the whole problem. Yeah. Okay. Now, that 25 cents for each code scanned is superfluous. It's a decoy. We don't need that. All we need to know is to figure out how many codes are. So that's all we care about is the codes. So let me show you just a mock-up of the codes over here. The first one is reserved for a digit. Then there's 4 letters, right? 4 letters. 1, 2, 3, 4. Okay. How many digits are available to put in that first slot with a digit? Only 7, because 3 are out. How many letters are fair game for the first letter? 24. How much are fair game for the second? Also 24, because your repetition is allowed. Also 24, also 24, repetition is allowed. So here's how many codes. It's the counting principle all over again. Multiply that all up. I don't know what that is. You get your calculators out. You get the number, and that is the amount of codes that are possible for this thing. It's the count. It turns out to be a fancy way of asking a counting principle question. That's all it comes down to. Okay, very good. The 18 is over. Use a calculator to find the exact answer. Let's go to another piece of paper and go to 19. Here we go. 19. 19 is a one-liner for once. For once, we get a really small question. Really short question. 19. The probability of... Oh, here it is. It's not so super short because it comes with a picture. Okay. Comes with a picture. Whatever this is, the dartboard that looks like a pizza, whatever it is. And, or a spinner. Dartboard, spinner, it doesn't matter. This, black, and then the Y. There's only 3 on each side. And then Y over here, that would be yellow, 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 and then red. All right? Yellow, black, red. Fine. Question. Really short question for once. What's the probability of B? Well, how many? What's the sample space? What's the denominator? 6. What's the numerator? There's two of them are B. 2 of them are black. So therefore it's 2 out of 6. Reduced, it's 1/3. And that's it. Problem over. Now, if they want decimal, when they talk about rounding, let's just talk about rounding for a second. 1/3 would turn into 0.666 going on forever. If they want you to round, let's say they want you to round to 1/100ths. This goes on forever. And your calculator might get you like forever at 0.66 until the end of the screen. But they say, let's say they want you to round it to hundredths. Hundredths. Let's say that's what they ask you. Okay, let me just go over rounding for a second. If you round it, that means you have to go through. The hundredths is here. This is tenths. This is hundredths. So you got to go 1 past the hundredths and look at this number. Is this between 0 and 4? No, it's 5 and above. That means you add a +1 here and you answer 0.67. That would be rounded to a hundredths. I just want to talk about rounding in case you have to worry about rounding when you get a decimal question, which is very possible that might happen. Here we go. Last question. Problem number 20. 10 toppings for pizza. I guess. It should be pizza. Yeah, pizza. 10 toppings. How many? Now they're gonna put 8 on the pizzas. So how many different 8 toppings? 8 topping pizzas. 8 topping pizzas are possible. Are possible. Okay, that is question. No, that is A. That is 20A. There's 2 parts to 20. Are possible. Okay, here we go. So here we go. Does the toppings does the difference in order with the toppings? No, there might be, but for our purposes, we're not going to assume there's any difference in the order of the topping. Maybe a chef will disagree with us, but we're going to assume there's no difference in order of the toppings. So how many toppings are there total? 10. How many are we taking at a time? 8. We want to know how many different 8 toppings possible are topping pizzas are possible. So it's C 10 8. What does that turn into? 10 over r factorial, and 10 minus 8 is 2 factorial. This turns into, take it with the 8, we have 10 times 9, get to 8, stop, over 2. What does that equal to? 45 in total of amount of toppings possible in this situation. Let me move up the paper. I want to get as much as I can out of there. I want to go to B. Totally separate question. B. What have you got? 14 cities. 14 cities that are possible to visit. Possible to visit. 14 cities. And there's going to be a keyword in here that's going to tell us whether it's combination or permutation. This person will only visit 3. Only has time. Only has time. Only visit 3. Okay. Okay. One's going to be on Monday. It's a whirlwind tour here. One on Monday. One on Tuesday. and one on Wednesday. That's how it's going to work. Here's the question, and it's got a keyword in there. How many different schedules, how many different schedules are possible? Are possible. No city is visited more than once. No city visited more than once. Okay, here's the story. You got three cities. Let's say it's B, R, and Y, right? Brooklyn, whatever, whatever this is, Y, whatever this is. Yokohama in Japan, Brooklyn, etc. And this would be Rotterdam. So now you can go to Brooklyn. You can go from Brooklyn to Rotterdam to Yokohama, or maybe you're going to Yokohama, Brooklyn, and then to Rotterdam. Those are different schedules. That means order is important. If its order is important, that tells you that the answer over here has got to be P, or order is important. 14 cities, only 3 of them are going to be visited, and then you have to do the P14 comma 3, which is equal to, and I got to clutter this up because I don't have any time to move to another piece of paper or anything like that. What is 14 permutation? It's 14 factorial over 14 minus 3, which is 11 factorial. And that equals to, sorry, I'm a real mess, 14 times 13 times 12. You do your calculator, and you've got the answer. All right, we'll stop here. 20th problem is in, and we're done.